Welcome to the Pythagorean Theorem and its converse. I'm Mr. Pi the Math Guy, and I'm going to be your host today. Let's get this geometry party started. The Pythagorean Theorem. Before we get into the Pythagorean Theorem, let's just review real quick about right triangles. Here we're told that A and B are the legs of the right triangle because they form the right angle. So here we have the side A and the side B. They are the legs of the right triangle. C is the hypotenuse of the right triangle because it is across from the right angle, and we can plainly see that there. Here's the actual Pythagorean theorem. In a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So if we square A, square B, add them together, it's going to be equal to c squared. And we see that down here, and you might be familiar with this. A squared plus b squared is equal to c squared. In fact, you should be familiar with this because this is what the distance formula is derived from. Here we have what are called Pythagorean triples. A Pythagorean triple is defined as a set of non-zero whole numbers a, b, and c that satisfies the equation a squared plus b squared is equal to c squared. Well, here are some common Pythagorean triples. Something that's interesting to note about them is these are often used on standardized tests such as the ACT and SAT. Here we have four common triples: 3, 4, 5, 5, 12, 13, 8, 15, 17, and 7, 24, and 25. And what I mean by a common triple is that these are whole numbers that satisfy the Pythagorean theorem. So if we take a look at 5, 12, and 13, that means if we take 5 squared, add it to 13 squared, it should be equal to, well, that should be 12 squared, and that will be equal to 13 squared. Well, if you know your squares pretty well, this gives 25 plus 144 is equal to 169. But when we add 25 to 144, 5 and 4 is 9, 4 and 2 is 6, we see that 169 is equal to 169. Therefore, 5, 12, 13 is a Pythagorean triple. Another thing to note is that we can always multiply triples by a particular number to get another triple. So we can multiply any of these triples or any other triples by the same number and change it to get another triple. In this case, if we took the Pythagorean triple 2, 4, and 5 and we multiplied it by 2, that would give us the Pythagorean triple 6, 8, and 10. If we multiplied 5, 12, and 13 by 3, that would give us another triple of 15, 36, and 39. If we took this one here and multiplied it by 4, that would give 32, 60, and 68. And if we took this one here and multiplied it by 5, say, that would give us 35, 120, and 125. And so here, Pythagorean triples, not only can we have them in their simplest form, but we can multiply them by numbers to get other Pythagorean triples. In example 1, we're going to be finding the length of the hypotenuse when we know the length of the legs, and here we're going to be finding the length of a leg when we know the length of the hypotenuse in a leg. So let's read the first part here. A right triangle has legs length 16 and 30. Find the length of the hypotenuse. Do the legs of the sides form a Pythagorean triple? We'll answer that when we're done finding the length of the other side here. Well, in this case, we're going to write down the Pythagorean theorem. A squared plus b squared is equal to c squared. And because we know A and B are the legs, we can substitute 16 and 30 in because we're told that these are the lengths of the legs. So here we'll put 16 squared plus 30 squared, and that has to be equal to, in this case, the hypotenuse, c squared. Well, when we square 16, that gives 256. When we square 30, that gives 900. Add those two together. That gives us 1,156. And that's equal to c squared. Now I'm going to do two things here. I'm going to take the square root and turn it around at the same time. So we end up with c being equal to the square root of 1,056. Now if you have a calculator, This is a very easy calculation. The square root of 1056 is equal to 34. So the length of the hypotenuse in this case is 34. Now to answer the question, do the lengths of the sides form a Pythagorean triple? In fact, they do form a Pythagorean triple because we started with two whole numbers, 16 and 30, and the last one is 34. And it's a whole number, so is it a Pythagorean triple? Yes, it is, because they are all whole numbers. And I often shorten Pythagorean theorem to Pythag theorem, THM. Or in this case, I guess that would be a triple, Pythagorean triple. In this one here, we're told that a right triangle has a leg length of 72 and a hypotenuse length of 97. Find the lengths of the other leg. Do the lengths of the sides form a Pythagorean triple? Well, going back to the Pythagorean theorem, a squared plus b squared is equal to c squared. What we have to do is substitute 72 in for either a or b. It really doesn't matter. I'll typically substitute it in for b, so I end up with a squared plus 72 squared is equal to 97 squared. And then when I square those numbers, the next step of my equation is going to be a squared plus 5,184, and that's going to be equal to 9,409. When I subtract 5,184 from each side, that'll leave me with a squared is equal to 4,225. I'll take the square root of each side, and that gives me a is equal to 65. So the sides of this triangle are 65, 72, 97. And it is a Pythagorean triple because they are all whole numbers. In example 2, we find ourselves being asked to find the value of x. Leave your answer in simplest radical form. So that's going to be important at the end, simplest radical form. Here we have a right triangle depicted, and what we're asked to find is the length of a leg. It's the length of a leg because we know the length of the hypotenuse is 12 because that's the side across from the right angle. So the Pythagorean theorem comes to mind. And in this case, I'm going to be solving for a, which is going to be x. X squared plus 10 squared is equal to 12 squared. Solving this equation, that gives us x squared plus 100 is equal to 144. Subtracting 100 from each side, we get x, and that should be x squared plus 100. We get x squared is equal to 44. Taking the square root of each side, that gives us x is equal to the square root of 44. Now here comes some factoring. The square root of 44 factors into the square root of 4 times the square root of 11. And we can take the square root of 44, which is 2. And since we can't take the square root of 11 or break the square root of 11 down into any perfect square numbers, the answer in this case, the value of x, or the length of this side, is 2 square roots of 11. In example 3, we're going to be doing some problem solving, and we're going to use the RISE method to do that. We organize ourselves in 4 quadrants where we put the information from reading the problem, then we'll illustrate the problem, then we will solve the problem, and then we will proceed to explain the problem. So let's read the problem and write down some important information, and that very well always should include the question of the problem. The rangers at Podunk National Park want to figure out how far it is across Lake Podunk. So we want to find the distance across Lake Podunk. To the nearest meter, how far is it from one dock to the other if you have to travel south 450 meters and east 300 meters? So we're going to go 450 meters south and then we're going to go 300 meters east. So illustrating this, we can see we're given a map here. So we're going to go from this dock down to this dock. And from here down, that's a distance of 450 meters because we're told we're going south 450 meters. Then from here to here, that would be a distance of 300 meters because that would be a traveling east. So what we end up having, a more simple diagram in our illustrate, is a right triangle with lengths 450 and 300 of the legs. What we need to find is C, the hypotenuse. So to solve this, we'd use the Pythagorean theorem saying a squared plus b squared is equal to c squared. What we're going to do is a squared plus, oops, that shouldn't be an a squared, that should be a 450 squared. Plus 300 squared is equal to c squared. Now I'm going to do a couple things here. What I'm going to do is switch it around, and I'm going to put the c squared over here. And that's with the symmetric property of equality. And then what I'm going to do is I'm going to proceed to show taking the square root in the same step, so that what I can plug into my calculator is the square root of 450 squared plus 300 squared. Now, I use a TI-84 calculator, and if you go second and then square root, and then you can type in 450 squared plus 300 squared, and then hit enter, what you're going to find is that the length of the hypotenuse in this case is 541 meters approximately. Now, in my explain portion, what I'll explain is that since the directions are south and east, I know it forms a right triangle. I'm going to abbreviate for south and east. South and east, it forms a right triangle. That I need to find the hypotenuse of. And in this case, that's 540 meters long. So the distance is 41 meters. So there's example 3 using the Pythagorean theorem and using a RISE, read, illustrate, solve, and explain, to complete that task. Here we have our second theorem of this video lesson, and it's the converse to the Pythagorean theorem. Remember, the converse is where you switch the hypothesis and the conclusion of an if-then statement. If the square of the length of one side of the triangle is equal to the sum of the squares of the lengths of the two other sides, then the triangle is a right triangle. What the converse does is, first off, allows us just to call it the Pythagorean theorem and know that it works both ways, and what it allows us to do, test the lengths, given lengths, say we're given 3 lengths, to determine if the triangle is a right triangle. There are 2 other theorems related to this that we're going to talk about shortly. In example 4, we're being asked to determine if the given triangle is a right triangle. So in this case, we're going to be using the converse of the Pythagorean theorem, which says that if these 2 sides squared, their sum is equal to the square of this side, then we do have, in fact, a triangle. So let's write this down, the Pythagorean theorem. A squared plus b squared is equal to c squared. Here's where the converse part really comes in, is we're testing that right there, that equality. So in this case, we end up with 15 squared plus 20 squared, and that's supposed to be equal to 25 squared. If you know your squares, if you have a good math teacher, they made you memorize the squares from 1 to 25. 15 squared is 225. 20 squared is 400. And that's supposed to be equal to the square of 25, which is 625. And in fact, 225 plus 400 is 625. So these sides do in fact form a right triangle. So this is a right triangle. Over here we're given 10, 15, and 20. It's always going to be good to note that the longest given side is going to be the side that you should put in for your hypotenuse. The hypotenuse is always going to be the longest side in a triangle, a right triangle, because it's across from the largest angle. So in this case we'll have 10 squared plus 15 squared, and that's supposed to be equal to 20 squared. Not 20 to the 0 power, but 20 squared. 10 squared is 100. 15 squared is 225, and 20 squared is 400. 100 plus 225 is 325, and that, of course, is not equal to 400. Therefore, we can conclude that this is not a right triangle. So there's using the converse of the Pythagorean theorem to determine if a triangle is or is not a right triangle. The last two theorems of this video lesson are the Triangle Inequality Theorems. Now, the textbook that I work from does not have a special name for them. I give it the Triangle Inequality Theorems because they really are about triangles and involve inequalities. If the square of the length of the longest side of a triangle is greater than the sum of the squares of the length of the two other sides, then the triangle is obtuse. So if the square of the hypotenuse is greater than, well, I guess we can't say hypotenuse, but the longest side, the square of the longest side is greater than the sum of the squares of the shorter sides, we know that it is an obtuse triangle. So if the longest side's square is greater than the square of the other two sides' sum, then it's obtuse. The other triangle inequality theorem is the same. And instead of reading it to you, let's just take a look at the inequality. If the square of the shortest side is less than the sum of the square of the other two sides of the triangle is acute. So we can use these two theorems along as well as or in conjunction with the converse of the Pythagorean theorem to determine what kind of triangle we are working with. It's another way to classify a triangle when you know the sides, or classify a triangle by angles when you know the lengths of some sides. In example 5, we are to classify the triangles whose sides lengths are 11, 12, 15 as acute, obtuse, or right. We're going to use the rise method to solving. Remember, when we rise up to a situation, we read the problem, we illustrate the problem, we solve the problem, then we explain the problem. So let's start to set this up. Rise, the read portion, we already read it. What we have to do is classify a triangle whose sides are 11, 12, 15 is acute, obtuse, or right. So what we have to do is we have to classify a triangle as acute, obtuse, or right. And that's going to be used with a combination of the converse of the Pythagorean theorem and the Triangle Inequality Theorems. Now, for our illustrate portion, we're simply going to draw a triangle and fill in the sides. This should be a pretty easy one. It doesn't have to be anything great, just so we get the idea that you understand what's going on. and it's 11, 12, and 15. And from the looks of this diagram, this would be the 90. And let me make it a better looking 5 there, 15. So we're going to use in the solve portion the Pythagorean theorem and the inequality theorems to test and to see what sign goes in there, whether it be equal, greater than, or less than. And actually, I'm going to rewrite that. I'm going to rewrite that with the hypotenuse on the left-hand side. And remember, this is the solve portion here. I'm going to write that with the hypotenuse, or the longest side, on the left-hand side. So putting that in, 15, that'd be 15 squared, and that's what we're testing is, how is that relationship going to be, or what is that relationship going to be? That'd be 11 squared plus 12 squared, and 15 squared is 225, 11 squared is 121, and 12 squared is 144. So doing the math here, 121 plus 144, 1 plus 4 is 5, 2 plus 4 is 6, and 1 plus 2 is 2. So 225 is less than 265. Therefore, this is an acute triangle. Okay? So in our explain portion, we're going to say since c squared is less than a squared plus b squared, which is interpreted since the longer side is less than the squares of the length of the other two sides, the triangle is acute. And this isn't necessarily a 90-degree angle, but that meant to be the angle that we were testing. So there's determining what kind of triangle you have using the triangle inequality theorems and the converse of the Pythagorean theorem and the rise method.